really excited to be hosting Rosa Vasquez Espinoza. She is a Peruvian chemical biologist, a National Geographic explorer. She's an educator, a conservationist, and award-winning artist. She founded the project Micro Amazon, so exploring the microscopic universe of extreme environments and unique animals in the Amazon rainforest to discover new molecules and enzymes for medicine and green chemistry. So I'm going to bring Rosa in with me right now. Hi, Rosa. How are you?
Hi, Joe. Great to see you. Thanks for having me. The festival has been awesome so far.
Excellent. I'm glad you've been able to tune in. It's been just a great week, and I'm so lucky to be able to host this event, to be able to share so many great stories. And I'm even more excited because we're going to take this playlist on Monday, and then we're going to share it out to our community of thousands of educators across North America, and they'll be able to share these stories with their classrooms as well. So it's going to be great.
Yeah, that's definitely super, super exciting.
All right. Well, Rosa, I'm going to let you take over for a little bit, share your story, and then we'll have a little Q&A time together.
Sounds great. Let me go ahead and share my screen now. Can you see the screen all right?
Yeah, we're ready. Looks awesome. Good.
So thank you so much, everyone, for tuning in. I'm feeling beyond honored to have been invited by Joe to join this Weekends Festival, which just represents a beautiful array of women in science. So my name is Rosa. I'm originally from Peru. And today I'll be telling you a story not only of who I am, how I got where I am right now, but the different exciting projects that I'm part of right now and things that I'm looking to be more involved with in the future. And this all revolve around the idea of the micro Amazon, the microscopic hidden universe of the Amazon rainforest, worlds that we haven't really fully seen yet and haven't taken into account when we talk about biodiversity of the jungle. But first, let me tell you a little bit about me and why this matters to me and where do I want to take it. As I mentioned, I come from Peru, and originally my family is from a very small town in the high Andes of Peru, in the mountains, where they had limited access to not only education, but medicine and hospitals. And here in this photo, I'm with my grandma, who became one of the leaders in her town for using traditional medicine, specifically plants, to treat different conditions whenever they didn't have access to doctors. And she brought all of this knowledge with her, with my family, whenever they migrated to the capital, Lima, which is where I was born and raised. And she created a small natural pharmacy in our backyard, where I basically grew up. I grew up learning about what plants she wanted to use to treat whether we had a stomachache, or if we wanted to cook certain things, or if we wanted to dye certain colors and dyes, etc. So I've always been fascinated by not only what nature can achieve in terms of medicine and agriculture and even cosmetics, but what's the science behind it. I had the opportunity to do an internship in China in 2014 in a traditional Chinese medicine hospital, where I saw how deeply involved is traditional medicine in their hospital systems. So you actually had one wing of the traditional Chinese medicine and one wing of their pharmaceutical-based medicine per se, and they were well integrated because they had a lot of scientific research behind the traditional medicine. And I feel like that's something that's missing in a lot of the countries in South America. And something else that how I got from here to the jungle was because by being able to visit different parts of my country since I was 15, I realized how little we know about all of these little nuances and the microscopic world of the jungle. So that led me to want to pursue a career in science. So I moved to the US when I was 18 to pursue a double degree in biochemistry and molecular biology, and recently graduated with my PhD in chemical biology, where I've been focusing on studying natural products that come from nature, specifically from microbes that live in sediment. But as Joe mentioned, I'm also very involved in the arts. I traveled before with dancing competitions and teaching workshops, and now I'm trying to integrate that back into the work I do by being able to highlight the culture behind the communities that we visit and work with. So today I'll tell you a story about the research that I've been involved with, as well as the educational projects and initiatives where we incorporate a lot of the science, but also a lot of the art, and the different communication avenues that I've been pursuing, so that we can all learn more about the jungle from a different perspective. Microbes, why should we care about them? Because a lot of the things I'll be talking to you about today revolve around the idea of microscopic organisms. They're found all around us, whether it's in the soil, in water, in our skin, in our bodies, in plants, in animals, in the air. And they're often too small to be seen by the naked eye. And traditionally, they've been super useful in medicine, such as penicillin, but also in food, cosmetics, materials, and more recently, in the last decade, they have been taking a newer role in the conversations around conservation of environments. Often when we've been hearing or talking about conservation, we consider the biodiversity that we can see with our naked eyes. So we're talking about plants, animals. However, the microorganisms are really the basis for everything around us and all of this beautiful life that we get to see with our eyes. So we need to have a stronger consideration of microbes when we talk about conservation, and that's a field that's starting to take more of a role now, but I think we still need more science on that aspect, more efforts on that, specifically when we talk about such a fragile ecosystem such as the Amazon rainforests. Microbes have also had a beautiful role in agriculture, helping us develop less toxic pesticides, for example, in green chemistry, to be able to make medicines that we need in a much cleaner way, as well as bioremediation, cleaning up oil spills, or even degrading plastics, which is work that is being carried out by amazing groups of scientists all around the world. And how does the microbes connect with the Amazon rainforest? One of the first times I went to the jungle, I was 15. And I already was introduced about on the concept of natural products and medicine coming from nature. And I knew a little bit about microbes. But then when I started to just doing a Google search about, okay, what do we know about the microorganisms in the jungle and what does that mean? I could barely find any information, especially when we talked about the Peruvian Amazon. So there's a lot of ecosystems here that haven't been explored. And nowadays, my main thought, and this is following what Sylvia said on Friday, more people have been to the moon than to the deep part of the oceans. And in a similar way, more people have been to the moon than I think more people have been studying the microorganisms in the Peruvian Amazon. And so I partnered with an amazing group of colleagues and scientists to explore the Boiling River, which is a really unique ecosystem. And if you have never heard about the Boiling River of Peru, I highly recommend that you go to TED Talks by Andres Russo, a dear friend and the director of the Boiling River Project, who made this ecosystem known to the world years ago. And it's a giant river that has no volcanic origins, and its traditional name is Shanaitin Pishka, which means boil with the heat of the sun. It goes really, really hot for about 4 miles. It's really wide, and it's been a mystery for all of us. Why is it boiling? Can anything live in there? Because most forms of life won't be able to resist temperatures really higher than 45 or 50 Celsius, because that's around where DNA starts to degrade. However, whenever we went to explore this area, we noticed that there was microscopic organisms just thriving in here. So here in this case, you can see different algae mats, which is when microbes form such large communities that all of a sudden now you can see them with your naked eyes. Meanwhile, any other forms of life, especially small mammals, were immediately dying when they were falling into the river. So there's many questions here that interest us, including how have these microorganisms evolved their own DNA to be able to thrive in these conditions. So that can teach us not only about how the river was formed, but also how did the evolution of life in the Amazon in this specific area may have occurred. And also by these microorganisms being able to flourish in such extreme conditions, not only have they evolved their DNA to do so, but they may be producing molecules that allow them to have this protective mechanism, which could be molecules that could be useful for us in the human world. And so nobody had looked deeply at this question. What are these extreme forms of microbes that we also know as extremophiles in the Boiling River? And so we decided to get a group together and do just that. So this was a project in collaboration with the University of Michigan, specifically the Sherman Laboratory and the Natural Product Drug Discovery Corps, as well as the Boiling River Project and the University Agraria in Lima, Peru, with local scientists. we traveled there a little bit before COVID hit around the world to collect samples throughout the river in the really hot spots, in the milder temperature spots, so that we could create basically a map of how does the microscopic life of the boiling river looks like, and being able to infer hypotheses from there. What does that mean to the life around it, the plants, the animals, and the geology of the system as well. I cannot share many results yet because we're putting this together into a publication as we speak. But basically, one of the main questions we also wanted to answer is, how many microbes can we find in 1 cubic centimeter of boiling river sediments? And so far, I can tell you with confidence that we're finding an immense diversity of unique microbes. Some of them don't even have a hit in any references available, which mean maybe new to describe science before. And so with this, we are creating the first large-scale biodiversity assessment of the boiling river and one of the first microbial maps of the Amazon rainforest, if not the first to my knowledge right now. And so that was one research project. Another one that I'm really excited to get started more towards the end of the year, once we wrap up the Boiling River project, is looking at Amazonian stingless bees. I've been working with colleagues in the Amazon for many years, and one of them has a deep interest in the medicinal use of insects in the Amazon by traditional medicine, by the different communities that still live around. And so he does great, beautiful work in ethnobotany to be able to collect this information and being able to leave a record of it, as some of the communities still are disappearing and all of the knowledge that they carry with them are disappearing as well. So we want to make sure that this doesn't happen. And one of these was the use of the medicinal honey that some of the Amazonian stingless bees produce. And also the concept that some of these bees have the ability to produce poisonous honey. So it's a really interesting project that we were able to connect with more deeply just a few months ago. I was able to travel to the communities, being able to meet them, understand the process that they follow to be able to keep these bees. The local government has been giving them a lot of training and support so that this can also become a source of circular economy for them. A lot of the communities were hit hard by COVID, not only by what we all were hit by, but also because they couldn't receive a lot of the economical relief support that the government was providing because of the distance and the difficulty, even in signal or in internet. So selling the honey from these bees became a big source for them. And it continues to be so. And so more and more communities are getting encouraged to learn what bees to keep around, how to keep them better, how to sell the honey, etc. And another interesting concept with this is that we need to remember bees are such an important pollinators in our ecosystem. So they're helping bringing up the agricultural crops around these areas. Actually, research done by my colleague Cesar over in Peru shows that if you are keeping bees in the Amazon, your agricultural crops will increase by 44%. And this is really important, especially when we consider areas that have been hit quite hard by deforestation and contamination in the jungle. So you'll be hearing more about this project soon, but we're going to be looking at the chemical composition of the honey, the medicinal and the poisonous honey, and as well as looking at the microbes that live within the bees and see if these may have any impact in how the honey is being made or the molecules that are found within them. I've also been very involved in education. The more I progressed in science, I have just been fascinated about the idea of sharing not only what we're learning and researching about, but what others are doing as well. And so I partner with different educators, and today I want to tell you about one of the most extraordinary educators I've been able to work with, Sherry Barton, a Nat Geo educator based in Idaho, and a hands-on scientific exploration experience that we developed in Yellowstone. So I partnered with Sherry to be able to share with her fourth grade classroom about the work I did in the Amazon and how you can use different expertise to study one ecosystem, as Andres has shown us, to be able to do in the Boiling River, but how can we use microbes to understand nature better, to understand how does the flora and the fauna of one ecosystem connect, how this concept of interconnectedness and macro to micro life. And so we had a semester-long engagement with a classroom where they got to ask me questions. I showed them how to use a microscope, how to collect samples from the wild to look for microbes, and how can this help us to be able to advocate for the conservation of endangered ecosystems better? And we finished this experience with a field trip in Yellowstone, where they were able to go around with me and being able to spot microbes in the wild, and what did that mean for some of the small plants that are able to grow at the hot temperatures of the Yellowstone boiling waters. What does that mean for the animals like the bison that are around them? We partner with local scientists as well to look at the microinvertebrates that are able to grow and live in the colder areas in Yellowstone, and being able to just really get the kids to feel as they can explore and they can be scientists. But we also incorporated a lot of art into this project, where they were able to not only paint what they were seeing, but also being able to compose a song about it with a local musician, and being able to share their thoughts and how they were processing everything that they were learning through music. I am also very passionate about communication, and one of the things I missed the most during the being quarantine was being able to talk with people and hearing their stories. Every time I was able to travel to the jungle, I was able to connect with so many people, hearing what they were researching about or their experiences, and that's something that really hit me being away from that. And so I decided to reconnect with people that were either currently in the jungle or working still with it, or their travels were impacted because of COVID. And I decided this time to document it and sharing that through small clips in social media, both in Spanish and English, and just being able to represent a wide array of really great scientists, explorers, artists, or educators that their work deserves to be highlighted even more. I also participate in different international science communication campaigns, such as this one on the recycling of the most common plastics in partnership with Nat Geo and Pepsi, where I was able to teach the audience what the different kinds of plastics that are out there, how to best recycle them, what does recycling means in comparison to upcycling, for example. This is in Spanish, but also available with English subtitles. And with that, I'm just really excited to continue with my research right now as a postdoctorate research associate at University of Michigan, and then within a few months moving into a more independent position. And my main goal is not only being able to continue with science that I find interesting, but that also elevates others, where we bring more of these experiences into more classrooms, getting more kids to be able to do this hands-on. I think that's something that I got to do unofficially as I was growing up with my grandma, because she would always just have me getting my hands dirty and being able to ask questions. And my mom and my dad were great at helping me push my mind in different directions. And I feel like that's something that we need more of, especially as we transition into more of a virtual world, inevitably. And so with that, I'm just always happy to chat and hear people's stories. So don't hesitate in reaching out. And thank you very much, Joe, for the opportunity.
All right. Of course, Rosa, what a great presentation, and what an amazing collection of projects you are working on. And the Boiling River, what an amazing ecosystem.
Yeah, we're very excited to be able to share about that. Hopefully within the next few months, I think we'll be ready. We have a great team. It's not only me by any means. We have an amazing local scientist named Felipe, who's completing his doctorate and has been doing a lot of the bioinformatic works. We're not only taking a look at the ecosystem of the Boiling River, but we wanted to be able to compare it at a deeper chemical level, a genetic level, with other similar ecosystems, and how do they differ, or how are they similar at this micro level. So that's something that we're very excited to be sharing about soon too.
Yeah, absolutely. So, you're finding a diverse group of microbes, of extremophiles in this environment. What benefit is it to know more about this community for the ecosystem as a whole?
Yeah, so a clear example, and I think this is a benefit to global humanity in general, it's by studying one of the extreme forms of microbes living in Yellowstone a long time ago, that a scientist was able to just ask the question, can anything live in here? And by being able to do that initial exploratory work, this led for us to being able to access now PCR, which has become such a staple to be able to detect COVID early on, because there's an enzyme within one of those extremophiles in Yellowstone that is able to resist high temperatures because of the nature of where it was found. And so it facilitates and speeds up the work that we're able to do in lab to amplify DNA and being able to detect whatever we're looking for. In this specific case, for what I'm talking about, is COVID. But I think it just shows how quickly nature evolves. And also, I think the aspect I come from is that microbes have this ability to evolve in real time, like really quickly. And so we also have microbes now that have been found being able to degrade plastic or degrade and consume petroleum, for example. So I think because of this inherent ability that they have to evolve in very extreme conditions where we wouldn't be able to survive or evolve so quickly as them, then we're able to harness that without injuring the environment, but instead being able to harness that information so that we can protect the environment better.
Awesome, Rosa. Rosa, do you ever feel like you're in a race against time? I mean, there's so much we can learn from the small world, from the plant world, we don't pay enough attention to. And there are medicinal value to microbes, to plant life. So do you feel sometimes like you're in a little bit of a race against time to document these species and look for, that green chemistry and the benefits that they can have?
Yes, absolutely. But I think the only way to fight against that is just to bring more people in with you. I think to remember that we cannot achieve any success in science alone, but rather collaboratively. And I think we need more locals doing work in their field. So I think we need not only more Peruvians doing work in Peru, but we need more Colombians doing work in the Colombian jungle, Brazilians, and etc. I think that facilitates the bridge into being able to not only access the location, but being able to better kind of think about where to collect or where to start, what areas do we need to preserve the most right now, so that we should be looking at the microorganisms and macro ones as well now before they get extinguished. So we get a certain information in the rest of the world here, but there's nothing like being in the field day by day. The local people that are there are the guardians of the location. And I think we need to be able to bring more of the science there and being able to create more international collaborations so that we can just progress at a faster speed than where we're losing everything.
And then you mentioned the local community and empowering others in the local community to be a part of these projects. Do you find that traditional knowledge is right on par with the science that you're bringing into the project?
Yeah, that's a great question. I think it's really interesting, yes, to realize that there's so much knowledge that is so important and relevant to the nature where the communities are found that they already know that we haven't even begun to tap yet. And so I think that's why the dialogue and the trust and building that consistently is really important. So not only do we learn from them, but that they also learn about what we're doing. And there's not only respect, but there's also fairness in the whole process. In our specific work, we make sure that they understand not only what we are coming to do and what our intentions are, but what are the results of our science do and how can that help them. So one of my dream goals is that the work that we do can help conserve areas better so that they can get better rights to be able to protect the lands and being able to take microbes into another layer of why should we protect this area. And I think we're getting close to being able at a stage to do that, and that makes me really excited.
Awesome. Rosa, one of the last projects you talked about was education with science communication. And I think science communication is being recognized more and more as being such an important part of projects, because if scientists are only talking to their peers, using language that's not accessible to broader communities, then, the work they're doing isn't having the benefit that it could. So what has bringing more science communication, how has that benefited projects like the Boiling River or the Yellowstone project?
Yeah, actually, I was reading this Twitter thread the other day where they were saying these last 2 years have become the most important for science journalists out there, in a way, of course, because when we consider the pandemics and the lack of information that goes around it. And this applies to all science projects out there. That's why I'm so passionate about this topic. I would say one of the biggest impacts of science communications that I've seen recently was learning that one of the institutes that I collaborate with in the northern Peruvian jungle, which is called the Institute of Investigations of the Peruvian Amazon, how they are losing funding because they don't have enough science communication strategies, which that's something they're working on right now. It's one of the largest institutions in the Amazon in South America, and who does incredible, thorough, rigorous scientific work. They have a lot of scientific publications going out every year. However, there was this lack of communication just because we don't have the training yet. There's a lot of universities that don't have science communication as a training strategy or module whenever we were training scientists. And I think that's something that we're missing. For Boiling River, I think it's just being able to bring a whole new layer of conversation when we talk about not only such an extreme environment, but when we talk about the Amazon rainforest, and then this concept that, hey, life goes beyond what we've been able to see. And that needs to be really present in us, because it makes us also realize we're losing way more than we're able to see right now. But there's also, I think, a lot of hope as well. And we just need to act quickly, as you say.
All right. Absolutely. You're so right about there not being enough education for science communication. If you look around a lot of major universities, they're available some spots, these courses, and many other places they're not. And I think every science team, every field team should include, a specialist in media who can kind of capture those moments and kind of share them more broadly with the general public.
Yeah, if I could just add one thing, for this last project of the Amazonian stingless bees, I was able to, through National Geographic, I was able to partner with an incredible photographer and artist based in Peru, named Ana Sotelo, who was here to bring that aspect. So we had this idea. She has a lot of interest in science and traditional medicine, and I've been wanting to integrate more of this artistic approach to what we do, in addition to the communication, because I think they go pair by pair, hand by hand, sorry. And so she was able to come with me, and we were able to create this set of visuals to communicate what we're doing, but also the conversations and the dialogue that we maintain with the locals throughout this entire process. We haven't been able to share that yet, but I think the results are astonishing, and to like how much we are able to communicate by being able to bring an expert into these field trips. So I agree with you.
Yeah, absolutely. Amazing, Rosa. I want to share a couple links here. Here's a link to the website, to the boilingriver.org, if you want to dive a little bit deeper into that project. I also want to share your Twitter and Instagram handles. So if people want to follow along, learn more about yourself, learn more about the work that you are doing, I think those are some great places to get started. And then, Rosa, I want to just thank you so much for joining us today. You're doing great work, bringing art into science, exploring a small world that's often ignored and forgotten. And then the education aspect of it is so important to empower people, not only in the local communities, but then to also kind of take it into a wider audience. So awesome, Rosa. Great work. Thank you so much for joining us today.
Thanks so much, Joe. And thank you for organizing this. This is awesome. Thank you.
All right. Have a great rest of the weekend.